Okay, so let's look at some more examples of how you can rationalize the denominator when there is a square root in the denominator. So the first example that I have on the slides is what happens when you have 8 over the square root of 2. Now, as you may remember, what we're going to end up doing is we want to get rid of that square root of 2 in the denominator. We're trying to clean this fraction up by making it so that there's only a whole number in the denominator. So I'm going to go ahead and I'm going to multiply both the top and the bottom by the square root of 2. Why would I do that? That seems so weird. Well, the reason that I would do that is whenever I have the square root of something times the square root of something, that's the same thing as the square root of that thing squared. And the whole point of a square root is it gets eliminated by a square, and so you end up with just 2. So that's what's going to happen in this case. The bottom is just going to be 2. The top, well, it's going to be 8 times the square root of 2, which is a little bit messy, but that's just the way it goes sometimes. Now, I think a few perceptive people might see that there's something that you can do right here too, right? So when I do 8 square root of 2 over 2, that 8 is actually 2 times 4. So I can eliminate the 2 in 2 times 4, and this is going to be simplified to just 4 square root of 2. So that's the answer to that one. Okay, so for number 2, I'm going to get rid of this stuff over here, but I'm going to leave that up there. Okay, so for number 2, what I'm going to do is, maybe I'll leave this for a second. What I'm going to do is, I'm looking at what happens when you have 5 over 3 square root of 7. And the reason that I wanted to do something like this is to show you what happens if there is already, if my square root is being multiplied by something in the denominator. It turns out what we're going to end up doing is we're not going to multiply both the top and the bottom by 3 square root of 7. We can just multiply it by the radical part of it. Okay? So we're going to multiply the top and the bottom just by the square root of 7. Okay? And what that means is the top is going to end up being 5 times the square root of 7, but the bottom is going to be just 3 times 7. Right? Because the square root of 7 times the square root of 7 is just 7. So you're going to end up with 5 square root of 7 over 3 times 7. And the other way to think of that is 5 square root of 7 over 21. Okay, so the next thing that we're going to do after silencing our cell phone is what happens if there's more than one thing in the denominator? What happens if there's a binomial in the denominator? So our next one looks like this. Number 3 says I've got 7x on the top. Okay, and I've got 5 minus the square root of 2 on the bottom. Okay, now this one is a little bit curious, and in order to do this one, you're going to need to remember one of your special product formulas. Let's kind of move over here a little bit, and let's remember that if I have a minus b times a plus b, okay, that's going to give me a squared minus b squared, right? A minus b times a plus b gives me a squared minus b squared, which means if I had something like, 3 minus x times 3 plus x, I would end up with 9, which is 3 squared, minus x squared. Well, why do I care? I care because, remember, squaring a square root is going to liberate the square root. So why I care is now I'm going to be able to multiply both the top and the bottom by 5 plus the square root of 2. Okay? Because when I do that, I end up with this pattern here. 3 minus x times 3 plus x gives me 9 minus x squared. In other words, I'm going to be able to now say that the bottom is whatever 5 squared is, right, which we know is 25, minus the square root of 2 squared, which is just 2, right? So 25 minus 2. Of course, on the top, I'm still going to have that 7x times 5 plus the square root of 2, which isn't going to look like anything nice. But the bottom is just going to end up being whatever 25 minus 2 is, which is actually 23, right? So I'm going to have, my answer is going to be 35x plus 7x square root of 2 over 23. Okay, that's what's going to be my answer for number 3. A little messy, but the nice part is, the thing that the mathematicians like is that just straight up 23 down there. Okay? Alright, and then finally we're going to look at number 4 from our examples, which is 3x squared over 2 plus the square root of x. Now, I only did this because it has the x squared in it, but it's really exactly like the one that we just did. We're going to multiply the top and the bottom by I forget what it's called, but I'll have that next video. I'll remember what that's called. I think it's a conjugate. By the conjugate of 2 plus square root of x, which is going to be 2 minus the square root of x, okay, on the top and the bottom. I think that is called the conjugate. I know with complex numbers, it's called the complex conjugate. So, I think I'm right. On the top, you're going to get 6x squared minus 3x squared square root of x. Okay? And on the bottom, you're going to get 4 minus x. And I can always take that top thing. Oh, no, I can't. Let's see. I can always take that top and I can factor some stuff out. I can say that this is 3x squared times 2 minus square root of x over 4 minus x or something like that. But right there, that is your answer.